Hi folks, welcome to another episode of NYC CNC. Today I wanted to show you guys this fixture plate that I use for parts that I like to keep in inventory. Nothing too crazy about it, but it's a really important efficiency tool for how I sort of run my shop. I use it to make this part right here, which I cut on the Torchmate, and then in the machining operations on the fixture plate, we face off the front, tap this, drill the holes, tap this for 5/16 by 18, and then ream this for a press fit for this captive pin. It's a good example of something that's important to me, which is I need to keep inventory in stock, and I want to have a plate that I can go grab and throw on the mill and make more parts when I need to without having to stress about it, if you will. But before I get into that, it's Thanksgiving, so happy Thanksgiving to the fellow American viewers out there. And I actually wanted to say thank you to you guys. I was looking at my YouTube stats, and just a year ago, I had about 2,500 viewers, and I'm at over 11,000 now, and it feels great. I get to do something I love every day, and I get to share it with you guys, and it's awesome. It means the world to me. So thank you very much for your engagement and being such great viewers. On that note, I've sort of done some reflecting on what my YouTube channel is about, and what's changed is when I started doing this in 2006, there weren't that many folks posting videos on YouTube on this sort of instructional and manufacturing content. Now there are a lot, and a lot of the guys are incredible. Guys like Keith Fenner out of the Cape, and Tubal Cain, and Ox Tools are all, seasoned metal workers who it's great that they are taking the time to post such good content to YouTube. Another one that I just found is a guy down in Florida, A-Bomb79, a little bit younger, does some great instructional videos, some heavy metal lathe work, really good. Would recommend checking his videos out as well. So for my channel, I want to focus more on the projects. I've started the series on making copper jacket bullets, and I think that's going to be awesome. It's so cool to work with a metal like copper and to make these dies and punches and die sets, to draw and cut these out. And it's heat treating, it's polishing, it's precision turning, it's sort of tool and die work. So more to come on that. And then you saw I just posted the video on the Arduino sorting machine. And to me, as a kid, robotics and motors and automation equipment was the coolest stuff, and to be able to do that and be competent enough, and it's so easy to get into nowadays. I can't encourage it enough if you're interested in that stuff, and I'm going to do more videos on that and share some of the projects that I've done and I've got on the agenda here. Anyways, going back to the fixture plate, it's in many ways encapsulates sort of what my shop is. It's still a home shop, but I'm able to cut out parts with my Torchmate, have a fixture plate that I can store in inventory on a rack, grab it, and I can make 100 parts in a few hours on the Tormach without a lot of intervention on my part. I think that's pretty cool. So let's take a closer look at the design. I'm no expert, but I've done it for a few years now. I used to over-engineer them. I've now learned how simple you can make these, how quick you can make them, how useful they are. So let's look at the CAD, the CAM, and then we'll hop over to the Tormach and cut some parts. So again, I'm no expert on this, but I've made a number of these now, and I've figured out some things I like and things I don't like. Some may be obvious, some may not, so let's dig in. The primary operations done are drilling, which makes the fixture a little bit easier to design because you don't have a lot of lateral forces. So the first thing is, anytime you can, have one clamp multiple parts. In this instance, it's a very simple strap clamp I made myself out of a piece of cold rolled, and I punched a hole in it with my Whitney punch press. Very easy to make and very easy to replace if you need to. As I mentioned, something I used to do was really over-engineer these. And I used to machine a whole plate with reliefs in it instead of using dowel pins. Folks, use dowel pins. Super easy to do, saves a lot of material, a lot of machining time, and you can reconfigure the same plate if you need to. And if you're done with the fixture, you can, if you want to save your dowel pins, knock them out and reuse them. This particular part comes off of plasma, so you've got to think about what that means. My plasma, like most, will cut with a small amount of angle on the edge of your part, as well as usually has a bit of dross on it, which is metal around the edges, usually on the bottom side of the part itself. I tumble my plasma cut parts, which actually knocks a lot of that dross off. But as you can see here, there is a relief machined in, and what that does is basically supports the part on the interior so that I'm not affected by a sharp edge or an edge that has dross on it. Use 3 points of contact if you can. You do have to be a little bit careful when you clamp your part down. Make sure it's contacted all the points and make sure that it's flat. That's a lot of times what I will do is not so much on this part because this is a pretty loose tolerance part, but I'll take a ruler and I'll lay it over all the parts, and that'll help you quickly tell if you've got a big chip under one. Mark your XY0. I've got 3 dimples in mine on the left corner that you probably cannot see here. You can check it in CAM as well, but I always like to make these as idiot-proof as I can and make sure that someone doesn't flip it, 180 degrees. An obvious point, and I'll show this in the CAD and CAM, but do everything you can while their part is fixtured. I don't want to touch this part again. After I take it off, the only thing I have to do is tap in that captive pin, which someone post a comment below if you can tell me how I can do that automatically on the mill. I'm all ears. And what else? I think that's about it for the fixture plate itself. Aluminum is fine, especially for a part like this. This will last thousands of pieces, and again, it's super. I mean, you can make one of these fixture plates in less than an hour. A few last comments. Think about your clamping and think about what goes wrong. Clamps do come loose sometimes, so is that going to hurt you? Is it going to damage the machine? Is it going to damage just 2 parts or many parts? Especially if you're going to run it unattended, which I'll be honest, I do a lot of times. This one is such a quick cycle that I'm usually stick around the shop. And finally, the other reason I like simple fixtures like this is if you do a higher volume, make a second one and load it offline and then just hot swap it in your machine so that the spindle's always running. It really makes a difference in your throughput, even in a home shop. Because this isn't a super high volume part for me, I went ahead and just did it with a 6-inch fixture plate, which limits me to about 16 pieces, but I can just throw it in my vise, which is easier for me than pulling it off and running a whole dedicated batch, which I will do with higher volume parts. It's certainly worth it, but it's just so easy to just drop this in the vise, zero it, and hit go. So let's take a look at the CAD and CAM real quick before we hop over to the machine. Here is the fixture model in a Libre. As you can see, it looks just like the part we were looking at. I'm not going to go into the whole design of this. There are some tips and tricks on the setup and the patterns and the assembly constraints. So let me know in the comments below. If you guys want to see a video on this, I could do a video, but it's probably a dedicated video. I don't think I want to go into that whole part right now. It may be boring for some folks. So here we are in Sprute. I've run this fixture for about a year now, and I probably run it every 2-3 months. So even with that, I find that I'm still tweaking it, and part of that has to do with tweaking the part itself too. So maybe that's not fair. But one of the questions I've got here is, do I go through and do a different spotting hole depth for the 1/4 inch versus the number 31 drill spots? And let's see here, we'll walk through these here. So yeah, spotting, drill 1/4 inches, tap just the end holes, pre-drill with a number 31, ream, and then I do and the last stop is the 2D contouring, which is trimming up the length. So the way I make this, plasma isn't always the most precise method, and more importantly, this part gets welded and I want it to be at a right angle. There's a separate fixture that does that, but I want this face to be square, and I want it to be accurate distance relative to the 3 holes. So the easiest way to do that is to cut it 20 or 30 thou longer, and while I've got it in this fixture, just run a 1/4 inch end mill along it, and in one operation trim it up. It makes life easier. So that's about it. I guess I'll run a quick simulation. Oh, the other thing, this is a more simple fixture, so I think I just imported this all as the part, but for sure on other fixtures I will import the pieces that are the actual fixture bottom and the clamps as fixtures in a Libre, which will help with collision detection, which can be really important if you're experimenting with different fixtures and different clamps and so forth. It's the worst feeling in the world to run an end mill through one The only thing that's annoying, I find, is a lot of times I will when I first make a fixture, I'll run the process with no parts in it. And sometimes, for instance, on this 2D trim, for instance, on this 2D cut along this edge here, I'll cut it deeper than the part itself, and it actually cuts a little bit into the aluminum fixture. That only happens once, but if you've got this base piece set as a fixture, it won't let you do that because it's trying to do collision detection with the fixture itself. But that's about it. Click run here and do a quick simulation. It's all the spots, all the 1/4 inch drills, the little drills, tapping, and the 2D contouring. So that's about it for the Sprute Cam side. Let's go see her in action. Okay, let's clean off our vise here. And make sure we use the right corner. Feels good. Okay. Oh, you know, I just remembered, I forgot to mention in the design, an obvious point, but drill those through holes, which I'll show you. Makes it a lot easier to allow you want to get the fixture cleaned up as quickly as you can when you go to put the next set of parts on. So through holes, let the chips fall through your drill holes a little easier. There we go. Okay, let's find our 0. Y. X, and then one of the things up for debate is how you want to set your Z height on a fixture. I am using the top of the workpiece here. That is not always the most precise given fluctuations in the workpiece or in having a chip or something below the one you happen to index off of. So for more precise parts, a lot of times I would index off the top of the fixture plate itself. But again, this one, it doesn't, it's mostly drilling operations, and in fact there's nothing that's really Z sensitive. So I just use the top of the part. And throw in our spot drill, and we're off. Okay. I always like to do a sanity check. Yep, looks good on the Z there. And the travel looks good on the Y. And likewise on the X. Here we go. Okay, there she is. Couple more things that I remembered while it was running. The center line of pins here are shared pins between the two inside row parts. It's always a nice way to save real estate and fixturing costs. And because these are plasma cut, I make sure to have my plasma cut starting and exit points where nowhere near the dowel pins. That way they don't mess up. Plasma tends to have a little bit of a messy entrance point. So again, that's one of the virtues of using pins over machine sidewall of some kind, is you can account for variations in the material like that. So anyways, that's a wrap for today, folks. Again, happy Thanksgiving. As always, if you've enjoyed this, please comment below. I'm guessing some of you may have recommendations on this fixture. I'm all ears. This one's worked for me pretty well, but hey, I love learning and hearing what you guys have to say. And that's all I got. Stay tuned for more, folks. Take care.